lesson is going to be on algebraic proofs. So we are officially starting the point in geometry where we're going to start doing two-column proofs. And to kind of ease our way into that, we're going to look at something called algebraic proofs. So we're really just going to be solving equations and then using some of these algebraic properties to justify our reasoning and justifying each step when we solve our equation. So the first four properties we use all the time when we solve equations. We just don't think about it. So all of these start with if A equals B, then. And for our addition property, if A equals B, then A plus C is going to equal B plus C. So that just says if we add C to the left side of our equation, we have to add C to the right side of our equation. So subtraction is going to say if A equals B, then A minus C equals B minus C. Our multiplication property is if A equals B, then A times C equals B times C. And the division property says if A equals B, then A divided by C equals B divided by C. Okay? Our substitution property is going to say if A equals B, then A can be substituted for B. So we saw this a lot, for example, when we were doing the segment addition property, segment addition postulate. If we had to solve for x and we found that x equaled 3, but then we wanted to find a segment length, we took that value, x equals 3, and we substituted that 3 back into whatever that expression was to find the length of whatever segment. Okay, that is using the substitution property. Our distributive property, all right, we should know that. So if we have A and then in parentheses B plus C, that's going to equal A times B plus A times C. And same thing if we have a subtraction. So that's going to be A times B minus A times C. And these last three properties are probably new, but they're going to be really important in geometry. So the first one's going to seem really silly. Our reflexive property is just that anything is equal to itself. So A is equal to A. We're not going to use this property too much, but we're going to use this in triangle congruence proofs quite a bit. So reflexive, you're thinking of looking into a mirror. When you see your reflection, it's the same exact thing. Okay, so A is equal to A, X is equal to X, anything is equal to itself. The symmetric property, all right, you want to think of like alignment of symmetry, right? Where you can just kind of switch and flip that order. So if A equals B, then B equals A. Okay, so almost the same thing, but we're just saying that we can kind of flip X equals 3, then 3 equals X. And our transitive property is kind of a special case of substitution. So if A equals B and B equals C, then A equals C. So some people kind of think of this as cutting out that middleman. If A is equal to B and B is equal to C, sometimes it helps students to kind of cross out that B because it's the same thing, and we just see that A equals C. Okay, that's our transitive property. It's a special type of substitution. Okay, so for the first couple examples, we are going to identify which algebraic property is represented in each example. Okay, so with number 1, it says if x plus 12 equals 20, then x equals 8. So I have to think about what is changing, all right, from my first statement to my second statement, right? My first equation to that second equation. And what I did in between this step was I subtracted 12 from both sides. So if I'm subtracting something from both sides, that's going to be my subtraction property of equality. I'm just going to abbreviate some of that there. Okay, that's our subtraction property of equality. Number 2, if AB equals BC, then BC equals AB. So it's the same exact thing. I'm just flipping the side of the equation that it's on. So that's going to be our symmetric property of equality. Okay. Number 3 says if AB equals 5 and AB plus BC equals 8, then 5 plus BC equals 8. So if I look over here, okay, what changed is I took this AB plus BC equals 8 and I replaced AB with 5. And the reason that I could replace that AB with 5 is because it tells me in the beginning those two are equal. So this would be an example of the substitution property. Okay. Number 4 is just x equals x, right? You see the same exact thing on both sides of the equation, so that's going to be our reflexive property of equality. Number 5 looks a little weird because we're looking at symbols, but these properties are true for, like, if we had all of these symbols represent numbers, it would still be the same thing. So we have this triangle is equal to this cross with dots, and that cross with dots is equal to a square. So then we know that triangle is equal to a square. So here we can kind of think of this as cutting out that middleman there. This is our transitive property. Okay. And then for number 6, it says if A minus B equals C, then A equals C plus B. All right, so if I want to see what I did to change each side of my equation, I added B to both sides. So this is going to be the addition property of equality. All right. For number 7, if 4x equals 44, then x equals 11. So here what I did to both sides, I divided both sides by 4. So that's going to be my division property of equality. You could also think of that as multiplying both sides by 1/4. So if you kind of thought of it that way, you could say multiplication property of equality, but I would probably say division for this one. And then number 8, if the measure of angle C equals 30 degrees, then 2 times the measure of angle C equals 60 degrees. So here we multiplied both sides of this equation by 2. So this is our multiplication property of equality. If I look at number 9, this looks like pretty basic distributive property. So I'm going to multiply that -4 to my x and to that -9. So this is our distributive property. And last but not least, it says if x equals -4, then 3x equals -12. So here, this is another example of multiplication. I am multiplying both sides by 3 here. So this is multiplication property of equality. Okay, so now we're going to start, we're kind of going to ease our way into this 2-column proof. So what we're doing is we have an equation here, an algebraic equation that we solved. So I have my steps and then I have my reasons. Once we officially kind of get into our proof, you're going to see, we're going to talk a little bit more about this given, but we're just going to think of as our starting equation. Okay, so we want to solve 2x plus 3 equals 9. All right, that is our given equation. The next step in solving my equation would be 2x equals 6. So how did I get from 2x plus 3 equals 9 to 2x equals 6? I subtracted 3 from both sides. So this is my subtraction property of equality. All right, and if it helps, you can really like put in that step there, what you're doing to get to that next step. And so now I'm at 2x equals 6. I want to move to x equals 3. So how did I get there? I divided both sides by 2. So this is a division property of equality. Okay, let's look at another one. So for number 2, we're starting with this equation 5, and then in parentheses x minus 4 equals 10. So that's our given equation that we want to solve. All right, so from my first to my second step here, I am distributing that 5 and multiplying it throughout my parentheses. So that's our distributive property. Right? Then I have 5x minus 20 equals 10. And my next line is 5x equals 30. So I'm adding 20 to both sides. So that's my addition property of equality. And then finally, I end with x equals 6, and I get that by dividing both sides by 5. So that's my division property of equality. Okay. All right, so like I said, we're just using these properties to give justifications or reasons for why we're doing each step in solving an equation, right? Okay, so now we're gonna put this in an official 2-column proof format. All right, so we're gonna see proofs all throughout geometry. All right, so let's talk about what a proof is. A proof is a logical argument that uses deductive reasoning to show that a statement is true. So a proof is going to consist of 2 columns. We have what's called our statements, and then we have the reasons. All right, all of your proofs are going to start with your given. Okay, so you're going to be given a certain piece of information, and then they end with your proof statement. Okay, so when you get a proof, it's going to look like this. You're going to have given A, B, C, and you want to prove X, Y, Z. All right, so your first statement is always going to be what your given is. Okay, so whatever your given is going to go right in that first line, and then your reason is given. All right, because that's your given information. Right? You're going to go through however many steps it might take, and then your last step, once you get to what you were trying to prove, so X, Y, Z, you are done. All right, and your reason would be whatever reasoning from the step before to your last step. Okay, you want to number these, and we'll kind of talk about that in a second, but you want to make sure that you're numbering your statements and your reasons, so that every statement has a reason or a justification for that statement. Okay, so let's look at the first two. The first two, it's really the same thing that we did up here, where we're going to be solving an equation and giving, we want to give the reasonings or the justifications for that. Okay, so number 1, our given is negative 9x equals 10 minus 4x. And we want to try to prove that x equals negative 2. So to prove that, we need to solve this equation. So our first statement is always our given. So we rewrote that negative 9x equals 10 minus 4x. In order to get to this next step here, we added 4x to both sides. So because I was adding something to both sides, this is going to be my addition property of equality. And then my last step is division. So this is, I divided both sides by negative 5. So this is my division property of equality. Okay. All right, for number 2 over here, it's the same thing. So we have our given statement. So negative 3r plus 10 equals 15r minus 8, and we want to try to prove that r equals 1. Okay, now there's a lot of different ways that you can solve an equation. If your statements are given to you, you kind of have to go in that order, even if you would do something slightly different. You want to be able to look at this work and see what's going or see what happened from each step and use the reason to justify that, even if you would solve it a little bit differently. So here for number 1, we rewrote our given, so our reason is given. Okay, so from my first to my second step, I see that I had this negative 3r, and now that's not on my left-hand side anymore. So I had to add that 3r to both sides. So this is my addition property of equality. Okay, then from step 2 to step 3, I added 8 to both sides, so that's going to be addition again. All right, and then I have 18 equals 18r. I can divide both sides by 18. That's my division property. And we can see in step 4, we have 1 equals r, which is really close to what we were trying to prove. We wanted to prove that r equals 1, but our last statement has to be exactly what is in our proof. So our last step is just to kind of flip what's on our equal sign. So if 1 equals r, then we know that r equals 1, and that was our symmetric property. Okay. Okay. Now our last couple examples, we have our given, we have our proof, and we have to come up with both sides now. So we have to come up with the statements and the reasons. When you do this, there is a chance that the way you would solve this equation, like I said, is different than the way that I solve it. As long as your statements and reasons match and everything is justified, it is okay if your proof is slightly different than someone else's, as long as, like I said, everything is backed up and all of the methods correctly. So let's start with number 3. So my first statement is going to be to rewrite my proof or my given exactly as I see it. So that's my given. Now, my next step here would be to combine like terms. So I want to combine this w and 2w. This is a little tricky. When I am combining like terms, okay, this is, even though I am technically adding w plus 2w, this is not the addition property of equality because I'm not adding something to both sides of my equation. I'm just saying that w plus 2w is the same thing as 3w. So this is actually an example of your substitution property. Okay. You want to be careful if you are abbreviating. You never want to abbreviate substitution as sub, because that could also look like subtraction. So I do abbreviate sometimes. Make sure that you give a couple more letters so no one mixes up if it's substitution or subtraction. Okay. So my next step, if I wanted to solve this equation, I would subtract 5w from both sides. So I would have negative 2w minus 2 equals 6. So this is subtraction property of equality. My next step would be to add 2 to both sides. So that's going to be my addition property of equality. And then my last step is to divide both sides by negative 2. W equals negative 4, and that's division. Okay, so I know that I'm done because my last statement, W equals negative 4, is exactly what we were trying to prove. Okay, our next one here, we start with our given. All right, so again, we are rewriting that exactly as I see it. We don't start simplifying, all right, or anything yet. Okay, now if I wanted to solve this equation, the first thing I want to do is distribute. And I'm going to distribute on both sides of my equation. So I'm just going to put both of that in one step. So negative 9t plus 18 equals 4t minus 60. So that's our distributive property. Now I'm going to subtract 4t from both sides. So that's negative 13t plus 18 equals negative 60. All right, and we were subtraction. Then I'm going to subtract 18 from both sides. So I have negative 13t equals negative 78. And my last step, again, is division. All right, just like when you're solving an equation, a lot of the times that last step is division. Property of equality. Okay. Now, for the last two, we're getting into some literal equations here where we have more than one variable. Again, it's the same idea. Okay, so I'm going to start with my given. So 2x minus 2y equals 5. All right, and here we want to solve for y. So if I wanted to solve for y, the first thing I'm going to do is subtract 2x from both sides. So I have negative 2y equals negative 2x plus 5. So that's subtraction. And my last step is going to be to divide everything by negative 2. So y equals x minus 5 over 2. And that is our division property of equality. Okay, and last but not least, we have our given is the formula for the area of a trapezoid. Okay, so we know that the area is equal to 1/2 the height times base 1 plus base 2. That's our given. We want to solve for h. So the first thing I'm going to do is multiply both sides by 2 so I can get rid of that 1/2. So 2a equals your height times base 1 plus base 2. All right, so this was multiplication. And finally, I can divide that b1 plus b2 all in one step. So I have 2a divided by base 1 plus base 2 equals your height. So that's the division property of equality. And I'm so close. Here my proof is that the height is equal to 2a divided by base 1 and base 2. I want to get that height to be on the left side, so this is going to be my symmetric property. And there you have it. That's our lesson on algebraic proofs. In the next lesson, we're going to still do algebraic proofs, but get a little bit of some geometric properties in there before we start like full geometric properties on segments and angles. So thank you so much for watching. If you have any questions, you can comment below.